Today we're going to look at the heart in more detail. We'll look at the anatomy, the different structures that you should be familiar with. And there'll be a video at the end, like an attached video with this assignment. And just a YouTube video. It's short. There's no video questions that you need to answer, but I do want you to watch it because it shows not real blood, but blood flowing through the heart and the path that it takes and how that works and how the contractions work to move blood through. All right, so we're going to start with number one. So this is the same page as your textbook page 436. All right, but number one, first of all, muscular tissue, cardiac tissue, muscular tissue, cardiac muscle make up the heart. Here is the thickest part of the heart lining, and that is called the myocardium. It contracts to pump blood. Then you have number two, which is the septum. This is the wall, muscular wall, that separates the heart into its left and its right side. The sides of the heart are based on the orientation of the person. So right now, this is a little weird to think about, but you kind of need to look at it in your mind backwards. So the sides are labeled from the perspective of the person that you're looking at. So this person, if this were someone's heart, it's kind of a mirror image to yours. So this, while you would say it's the right, is actually the left. And this is actually the right. So don't let that confuse you because it is a little bit confusing. But this is the person's heart. So this would be the person's right side and the person's left side. Okay, so again, this is the septum. It separates the right from the left and helps to separate some of the chambers of the heart. Now, as you guys have learned in the videos at the beginning of this section that we watched last week, there are 4 chambers to the heart. So 3 and 4 right here are the smaller chambers, and they are the atria. Atrium is singular. So this is the atrium. This is an atrium. Atria, the smaller chambers are called the atria. The 2 bottom chambers are larger, and those are the ventricles. So this is ventricle 5, labeled 5. This is the ventricle, and this is the ventricle. And again, this would be the person's left ventricle and the person's right ventricle. So again, 2 atria, 2 ventricles. Atria are the upper chambers, ventricles are the lower chambers, and the atria are smaller. This is the person's right atria and the person's left atrium. Okay, right atrium, left atrium, right ventricle, left ventricle. All right, so how does blood come into the heart? Blood enters the heart actually in several places. Oxygen depleted blood, meaning blood that has dropped off its oxygen and makes its way back, and that's called deoxygenated blood. Okay. It enters in down here at number 7, and that is the inferior vena. This is where blood comes back from the body into the heart without oxygen. It does not have, currently at this point, does not have oxygen. And then this deoxygenated blood, I should say this is deoxygenated blood from the lower body. So notice it's on the underside of the heart, is coming from the lower part of your body. As compared to the superior, meaning above. Inferior doesn't mean small or less worthy, it means below or underneath kind of. Superior means above, but not better than. It just means it's literally above. So the superior vena cava also brings in deoxygenated blood, but from above, any blood that's coming from above the diaphragm. Okay, so from the lower body, it enters here to the inferior vena cava, and here, the superior vena cava. Deoxygenated blood from the, so deoxygenated blood from the upper body, deoxygenated blood from the lower body. And then if you come up here to number 9, you'll see the pulmonary veins. Now, these two little fellas deliver oxygenated blood to the heart. Okay, and that oxygenated blood enters in at the left atrium. So here, okay, remember this is the person's left atrium. All right, left atrium. Okay. Now it also leaves the heart through here, this number 10. Okay, these are the pulmonary arteries. Now, pulmonary, if CPR, cardiac pulmonary resuscitation, you're compressing the lungs. So pulmonary deals with the lungs. And so these two guys are going to have blood go through them and head to the lungs. Why? To get oxygenated, okay? Then, what are we going to do with that oxygenated blood as it goes through the lungs? As we talked about with the respiratory system, it's going to pick up some oxygen through those capillaries and diffusion at work. The oxygenated blood leaves the left ventricle through the aorta, and that's number 11 right here. So blood comes up right here, and this is one of the strongest arteries in the body, okay? And it's gonna go, it arches all the way around and forks to the upper and lower parts of the body carrying blood. All right. So now with that being said, how does all this really work? What happens in a heartbeat? Blood comes into the heart, blood leaves the heart. Sometimes blood leaves the heart, goes to the lungs. Sometimes blood leaves the heart and goes to the rest of the body. Deoxygenated blood leaves the heart, heads down to the lungs, and then comes back and then gets pumped out to the rest of the body. So you can imagine that there's a lot of pathways, and one of those videos described it kind of as a figure 8 pathway, which is why I want you to go and watch the video that I'm going to post that goes along with this, because it's going to show you how that figure 8 motion works. The other video did a little bit too, but you'll see it in this video as well. So I want you to watch it. Again, it's only about 2 minutes of your life, and I want you to watch it and pay attention to it so you can see how that blood flows. All right, there are 2 parts to a heartbeat, and this is called the cardiac cycle. So for every cycle, there's a complete contraction and a complete relaxation. And both sides, left and right, are working at the same time to relax and contract. So your heart, if you've measured your pulse at a normal resting rate, it sometimes, this is even normal resting calmly, sometimes it's happening 60, 70, 80 times per minute, that complete relaxation and contraction, relaxation and contraction, relaxation and contraction. So that when you feel your pulse, that's actually what you're measuring, how many times you complete a cardiac cycle. Okay, so what happens is the heart relaxes. When the heart relaxes, deoxygenated blood flows from the body through the vena cava into the right atrium. Okay. Oxygenated blood, all that happening at the same time. So you have deoxygenated blood coming in, either here or here, depending on what part of the body it's coming from. And then oxygenated blood flows from the pulmonary veins into the left atrium. Okay. Then we get the nervous system involved. And then a nerve pulse at the right atrium activates the heart into contracting. So it was relaxed and now it's getting ready to contract. That nerve pulse is what you would call, some people have to get pacemakers installed if their tickers aren't working quite right. Well, you have one naturally, and so you don't need an artificial one unless your natural one doesn't do what it's supposed to do. Okay? So you have this nervous system, natural built-in pacemaker that's telling your heart how often it needs to begin to contract and get the contraction started. So the left and the right atria contract first. And what that does is that squeezes the oxygenated blood into the left ventricle. And hang on, I just pointed to the wrong thing. Sorry. Let me go back. So the left and right atria up here, the upstairs chambers, those contract first. I put it down here. I'm sorry. So the left and right, those atria contract first. What that does is it sends oxygenated blood into the left ventricle and deoxygenated blood into the right ventricle. So all of this is happening at the same time. So at any given time within your heart, you have oxygenated blood coming out, deoxygenated blood coming in. You have, your left side is working to do one thing and your right side is working to do another. And it's not contradictory. It has to happen in this pattern to keep your blood fully oxygenated all the way, or keep your body fully oxygenated. You have to have some that's getting replenished, and the replenished has to be going out to make room to get more in there to be replenished again. All right, so deoxygenated blood goes into the right ventricle, and about I think your book, what is it? I'm looking here. And about 0.1 seconds later, the impulse reaches the ventricles after they have filled with blood. And then oxygenated blood is squeezed out of the left ventricle into the aorta. Now remember which one was the aorta? It's this big one right here, this big artery, to supply the body, because blood can go out into various directions. And this starts the supply of oxygenated blood to the rest of the body. Deoxygenated blood at the same time is squeezed out of the right ventricle and into the pulmonary artery so that it could go down to the lungs and get more oxygen. Okay? So this is how, if you remember that figure 8 cycle, it's always cycling, trying to get oxygenated blood out of the heart, deoxygenated blood back into the lungs, oxygenated blood out of the heart into the rest of the body, deoxygenated blood back into the heart to get pumped out to the lungs to get reoxygenated. Okay, so that's that figure 8 cycle. Oxygenated blood goes out into the body. Deoxygenated blood has to get shipped back to the lungs to get reoxygenated. All right. Now, to finish this up, why do we care? Well, every system in your body needs blood. So pulmonary circulation is key, and what that means is that's the flow of blood to the lungs. That's the carrying the deoxygenated blood to the lungs for gas exchange, that diffusion process. Then you go to systemic circulation. So that's the flow of oxygenated blood from the left ventricle to the extremities. That requires much more blood because it has to cover more distance, okay? So why, again, to recap the importance of blood, why do we need it? Well, it carries oxygen. It also carries carbon dioxide because we got to get rid of that. It takes nutrients throughout our body from food that we eat and various other waste products. It helps us cycle those, whether we...
Dr. Scott W. Atlas writes, quote, "By now everyone recognizes Dr. Anthony Fauci, the director of the National
I have no idea why that is talking, and I am so sorry about that. I don't know what I clicked to make that noise happen. But anyway, sorry about that. But these waste products have to get out. And sometimes that means that, you know, we've eaten something that we shouldn't, you're sick. Sometimes that your blood plays a vital role in clearing those diseases, not only with your white blood cells, but also getting just any kind of toxins out of your body that you need to get rid of. But I'm going to stop here with the circulatory system. I hope you guys have a great weekend. Finish watching this video, watch the other video that I post, and there will be a couple of questions to answer. But I hope you guys have a great long weekend, and I will check back with you, see you on Tuesday of next week.